All right, today's lesson is about work, and work is going to be either going to be in foot-pounds or joules for the sake of what we're doing. And they're going to give us the force in either pounds or newtons, and the distance in feet or meters. So pounds go with feet, newtons go with meters. A foot-pound is a unit of work, and a newton-meter, also known as a joule, is a unit of work. Now, the only other unit they might give you today is going to be mass in kilograms. If mass is given in kilograms, you must multiply by the absolute value acceleration due to gravity, 9.8 meters per second squared. And if you remember from physics, a kilogram meters per second squared is the definition of a newton. So if you multiply that. So, and if we're assuming we're on Earth for every problem. If we're in a different planet, we'd have to know the acceleration due to gravity on that planet if we knew the mass of the object. All right, so if you get a specific force and a specific distance, you multiply them together, you get work. Simple. All right. If, on the other hand, you get a variable force, so depending on where you're at, the force changes. So if you're at x equals 1, it's got a force of 20 pounds. At x equals 2 now it's 40 pounds. At x equals 3 is 60 pounds. That'd be a 20x would be the force equation. All right. But if you get a variable force, you simply integrate the force over the interval of the distance, the beginning distance to the ending distance, and you will end up with the correct amount of work for that situation too. So we'll try it out. Example 3 is going to be this one. Example 1 is this one with the mass, and example 2 is going to be, I think, feet and pounds. So, all right, here we go. Example 1. How much work is done in lifting a 1.2 kilogram book off the floor to put it on a desk that's 0.7 meters high? Use the fact that acceleration due to gravity is 9.8 meters per second squared. So, in order to define work, we have to know force, and we have to know distance. Okay? Distance, of course, is 0.7 meters, because that's how high we're lifting it, so 0.7 meters. The force must be in newtons. We don't have newtons. We have kilograms. So again, if I see kilograms, I'm going to multiply kilograms times 9.8 meters per second squared. And if I multiply 1.2 times 9.8, that comes out to 11.76. And that's 11.76 kilogram meters per second squared, better known as a newton. Once I know what the force is in newtons, distance is in meters, I'm able to find the work. Work is simply going to be the force times the distance that comes out to 8.232. Again, that's 8.232 newton meters, but we're going to call that joules.